Hello, welcome to my channel. We will be doing, we will solve this past exam paper. It is from May June 2025. Okay, you can see it here, and it is mathematics paper 4 mechanics. Okay, we did two questions in the last video, so we will continue from there. Okay, so I hope you have no problem with the first two questions. Question number one and question number two. Okay, now we will do question number three. Okay, so you can see the scenario. There's a mass P, which is m kilograms. So mg is its weight. Okay, and there are two strings. One is this one. The tension in this string is 35 Newton, and we need to calculate the tension in this string. So this T we need to find out. Okay, uh, so there are two angles. Let me call this angle theta, and this angle, let me call alpha. Okay, we need to calculate the sine and cosine of these two angles. Okay, for theta, you can see that sine of theta is easy. It is 2.4 over 2.6, right? And this will simplify to 12 inverse 13. Okay, let me make it little thin. This is too thick. Okay, now imagine there's a triangle and sine. This is 12 and this is 13. Only then the sine of this angle will be 12 over 13. Okay. Now, if it is 12 and this is 13, then you can use Pythagoras theorem and find that this on the third side is 5. So it means cosine of theta would be 5 over 13. Right? Now, you can see that this alpha, it is a complementary angle of theta. What does it mean? That this alpha is equal to 180 minus 90. Remember, this is 90 degree. And minus theta. So 180 minus 90 is 90 minus theta. Okay. Remember, if two angles, the sum of two angles is 90, then they are called complementary of each other. And um, one other thing is that if I have a right angle triangle like this is 90 degree, then these two angles are complementary of each other because their sum is 90 degree, right? So if I call theta 1 and this is theta 2, then you can see that sine of theta 1 is same as cosine of theta 2, right? So if two angles are complementary of each other, then one sine is the cosine of the other. So with this same logic, I conclude that sine of alpha would be same as cosine of theta, and this is 5 over 13. Similarly, cosine of alpha is going to be sine of theta, which is 12 over 13. Okay, so these values we are going to use again and again. That's why I wrote them in the beginning. Okay, let me make sure sine of alpha is 5. Yeah, okay. Now, uh, you see, since this whole setup is in equilibrium, we can make this free body diagram. I have this mass M. So there are two forces. One force is acting T1, or let me call it T, which is 35 Newton. It is known. And the other one is here, and the angle between them is 90 degree. And this tension we do not know. We need to calculate this one. Similarly, the mass of this object, we need to calculate the mass as well. Okay. Now, you know that if something is in equilibrium, that we said that the sum of all forces along x-axis is 0. What does it mean? You see, there are two forces along x-axis. I can resolve this force into its x component and y component, and I get rid of this one. So what is the x component? You can see it is 35 times uh, cosine of alpha, right? This is in this direction. In the same way, the x component of this tension force, it is going to be negative, and tension is T, and then I will say cosine of theta, and that must be equal to 0. Okay, I hope you understand what I'm doing. This is very important relationship, what I just wrote. So from here you can see that this T into cosine of theta. What was cosine of theta? It was 5 by 13. Okay, this is equal to 35, and cosine of alpha, which is 12 by 13. So from here we conclude that this T is 3 into 12 over 5. Am I right? T is, sorry, 35, not 3. Why did I say 30? T, yes, this is 35. 35 into cos of alpha is 12 by, yeah. So this is 35 times 5 over 5. 35 times 12 over 5. So this comes out to be 84 Newton. Okay. Now I will use this equation. The sum of all forces along y-axis is 0. What does it mean? There are two forces in the positive y direction, one force in the negative y direction. So the sum of these two positive forces is going to be 35, and sine of alpha, this is the y component of this 35 Newton force, but acting vertically upward, plus this T times sine of theta. This is the vertical component of this tension force which we need to calculate. And this must be equal to the downward force, which is M and G on the. Okay, I hope this is clear. So 35, what is sine of alpha? Sine of alpha is 5 by 13, and plus tension, we already have calculated, this is 84, into sine of theta, and sine of theta was 12 over 13. So this is 12 over 13, and this is equal to mg. So m we need to calculate, and g is 10, so I will use it in the next step. Okay, so what is this all equal to? Mg equals, if we simplify this whole thing, 35, 5 by 13, 84. So this comes out to be 91. So from here, M is 91 over G. We take G as 10. So this is going to be 91 over 10, or 9.1. Okay, 9.1 kilogram. So this was not a difficult question, I believe. Okay, now this one. Question number 2. A car is traveling along a straight horizontal road. The car passes through a point A on the road, traveling at a speed of 50 meters per second. And then, okay, so at time 0, the car already have a speed of 15 meters per second. Okay. and then accelerates uniformly at this for 30 seconds. So for 30 seconds, this is time 30 seconds, it keeps accelerating. So what will be its speed? We know that Vf equals Vi plus At. So its initial speed is 15 meter per second. Its acceleration is given as 0.4 meter per second square. So 0.4, and it accelerates for 30 seconds, right? So 30 plus 0.4, how much is it? Let it calculate. 15 plus 0.4 times 30. This is 27. Okay, so it accelerates for 30 seconds and reach a speed of 27 meter per second. Okay, then it keeps going with a constant speed for some time, and that time is known as 3t seconds. So this is the interval for which it keeps going with a constant speed. So at this point, the time is 30 plus 3t. Then for next t, so this is 30 plus 4t. It keeps deaccelerating at 0.2 meter per second. So here the acceleration was 0.4, 0.4 meter per second square. And here it is decelerating with 0.2. So it goes down. So this is minus 0.2 meter per second square. And this is where we have point B. So it started at point A and it reached at point B. Okay. Since we do not know the exact value of this capital T, so I cannot find the exact value of this final speed. Okay, on the given axis, sketch a velocity time graph for the motion of the car between point A and B. Yeah, this is what we finished. Okay, next question is the distance from A to B is 2,750 meters. Find the value of T. Okay, very good. You see, the distance we can find by finding the area under the velocity time curve, right? So what I will do, I will find the total area under this curve, under this sketch, and I will make it equal to 2,750. Okay, so how much is the area? For the first section, which is 30 seconds long, this is a trapezoid, right? So how can I find the area? The area is 15 plus 27, and its mean value times 30. I hope you remember this expression. So this is the formula for the area of this first trapezoid plus the next section is a rectangle. Okay, so the area of this rectangle is 3t times 27. Okay, plus again we have a trapezoid. So the area of this one is going to be 27 plus. Okay, what is the speed over here? Right? Okay, you remember Vf equals Vi plus At. So initial speed was 27 plus acceleration is minus 0.2 meter per second square. And the time is capital T. So this comes out to be 27 minus 0.2 T. Okay, so into 27, this height, I will add the other height, which is 27 minus 0.2 T. Okay, and I will divide this whole thing by 2. So this is the average, and I multiply by capital T. So this thing will give you the total area of this trapezoid. And this all area is equal to 2,750. Okay, I hope this is all clear what we are doing and why we are doing. Okay, so this thing 15 times, I hope you understand, this is going to be 630 plus 27 times 3t is basically 81t, and this one, you can see it is 27 plus 27 divided by 2 is going to be 27, and minus 0.1 t, and this is being multiplied by this one, this capital T. So if I open this bracket, it will become plus 27t and minus 0.1 t square, and this is all equal to 2750. I have this all clear. So if I multiply with negative, it's going to be 0.1 t square, and then I add them together and it's going to become minus 108 t and plus one. Yes, I'm multiplying with negative everything. This is plus 2120 and this is equal to 0. Okay. 81 plus 27 is 108. So we have to multiply with negative, so it becomes negative. And from negative 2750, I will add 620 and then again multiply everything with negative. Okay, so from here, this t equals minus b plus minus under the root b squared minus 4a and c is 2120 all under the root and divided by 2 times 0.1. Okay. So when I calculate this number, it gives me two answers. One is 1060 and the other one is 20, right? So by assuming this magnitudes, you can guess so this is going to be 20 and not this one. And we can prove that this is not the true, because if I assume this much time, then the uh, speed which I calculated here. Yeah, that's going to be much negative. Okay, so this is not a realistic value 1060. So right value of t is 20. Okay, so what is the next problem here? Yes. Okay, the next part of this problem is that the car continue its journey from B, deaccelerating uniformly at 0.5 meter thing until it comes to rest. So basically, what speed time curve we have it? Oh my goodness, it's difficult to make a straight line to me. Okay, so let's say this was a time axis, this is speed axis. So we saw that it started from 15, reached to 27, continued for 27, and then it has some deacceleration. And now they're saying this was point B, right? This was point A. We did it in part one. Okay, from here, it deaccelerates at a higher rate, I believe, yes. So it comes to rest after some time. Remember, this time was what was it? 3t, 30 plus 4t, 30 plus 4t. Now, what is this time? Okay, uh, we know that t came out to be 20. So the speed over here, which we calculated as uh, 27 minus 0.2t. 27 minus 0.2t. Uh, 27 minus 0.2 and t we have found as 20. So this comes up to 23. Okay. So the speed over here was 23, and how much time it will take to uh, stop to come to zero? You can see uh, VF equals VI plus AT. So from here, if I isolate T, it is VF minus VI over A. So final speed is 0, initial speed is 23, and acceleration was minus 0.5. So this will give me 46. Okay, so basically this time is 46 seconds. So I need to find the total distance. The car continues journey from B, okay, until address. Find the total distance from A to C. Okay, I already know the distance from A to B. This is given as 2750. So I just need to find the distance from B to C. Okay, this is point C. So the distance from B to C, distance BC, it is the area of this triangle, right? And this triangle is half, and to base is 46 into height, which is 23. So it will be 23 square, and 23 square is how much? Whatever it is, we can 23 square, it is 529. So the total distance from A to C is going to be 2750 plus 529. It comes out to be 2750. So it is 32, 79, 79. Okay, so it was easy. I will stop over here. I hope you enjoyed it. If you have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.